Alright, so starting with 8.1, looking here, all you're looking at is the GCF, which is the greatest common factor. Whoa, sorry. Okay, so a lot of times with these, like, let's just even take a look at example 1, this 18 and 42 here. So when you're doing this one, you want to go through and see what the greatest common factor is. So we know they're both divisible by 2. So we know we got 2 and 9, and then we got, this becomes 3 and 3. Okay, so then 42, we have 2 and 21. 21 becomes 3 and 7. Okay, so what's the largest number that they have in common? So just looking at your choices here, like this becomes 2 times 3 times 3. This becomes 2 times 3 times 7. Okay, so their largest number that they have in common is this 2 times 3, which is 6. So that's their greatest common factor. Okay, so going over and then looking at B, now we have numbers and variables. Sorry, my son's like burping in this video. Okay, so first focus on 11 and 33. So 11 is only 11 times 1, and 33 is only 3 times 11. So they both have 11. Okay, so we have the coefficient part is 11, and then we have x cubed and x to the 5th. So if we're looking at how many x's, this one has 3, and this one has 5, but this one still has 3 within it. So the greatest that they have between them is x cubed. Okay, so with all of these, that's what you're kind of looking at. You're just simplifying, pulling out what the greatest thing in common is. Okay, so I'll just kind of run through, we'll do one more really quick. All right, so just looking at 11 and 35. So we know that 11 is only 11 times 1, and 35 we have 7 times 5. So they don't have anything in common, so we're not even going to use the coefficients, okay? So now we're going to look at the variables. So the variables, you have x to the 5th and x squared. Well, there's 5 in the first one and there's 2 in the second one. So the greatest common factor among the two of them is just x squared. And then y squared and y cubed. So between them both, the greatest amount that they both have is just 2 of them. Okay, so then together, since we couldn't use the coefficients at all, they didn't have anything in common, we just put together x squared, y squared. That's the largest thing that you could divide out of both of them. Okay? All right, so looking at, what's on this next page? Okay, so now factor expressions. So those were just, before were just individual, whatever it's called, terms, and whereas now they're actual expressions. So you can look and see that we're adding and subtracting things. So it's the same process though. If you're just looking at what the two have in common. So looking at 24 and 48. Okay, well, we know that this is 24 and 1. We know this is 24 and 2. So right away you should recognize that 24 is the largest number that you can pull out between the both of them. You can simply go through and keep factoring, but you need to start recognizing what the largest thing is. So now variable wise, this has an x and this has a y, so they're not the same. So when we're pulling out the GCF, we're basically, let me erase, maybe, there we go, so we have room. You're dividing out what they have in common. So if we decided 24 was the GCF, that's what we're dividing out. So whatever you divide out goes out in front, and then what's remaining? Well, 24 divided by 24 is just 1, so we just have that x. 48 divided by 24 is 2, but then we still have the y. So this is our final answer in factored form. Okay? So factoring is basically just the backwards of distributing. Okay? So let me jump down to, what's another good one? We'll look at D because there's 3 terms here. Okay, so for this one, we're looking at each one what they have in common. This has a coefficient of 1, negative 18, and 22. So there's the only number that they're all divisible by is 1. So we don't even have to worry about the coefficients. So we're just going to look at the x's. This one, the first term has 4 x's. This one has 3, and this one only has 1. So 1 is the minimum that we can pull out. or the maximum that we can pull out. So we're going to divide everything by x. And then that's what's going to be out in front. So what's left over? Well, we're going to use our exponents rule. 4 minus 1 is 3. 3 minus 1 gives us x squared. And x over x cancels out, so we just have plus 22. And then you're done. Okay? All right, so those are all similar. If you want more help on any of those, just let me know. But let's jump down to the factoring out the GCF using, this is actually using grouping. Okay, so that's what this is talking about right here, is this grouping thing. But instead of going through those steps, I'll just explain what's going on. So this is what we're going to see later on in the sections. But before you get to that, we just kind of want to expose you guys to looking at what each group has in common. So you should be able to see from what I underlined, they both have that 2y plus 5. Okay, so if they both have the 2y plus 5, then you're basically dividing out the 2y plus 5 as a GCF from both. So remember, whenever you divide something out as a GCF, that goes out in front. So then remaining, look, these are canceled, these are gone. So all that's left over is 5x minus 9. And then you're in factored form. Okay? So looking over at the next one, what do they have in common? X plus 1 and an x plus 1. So from there, we can divide x plus 1 from both groups. And whatever you divide out as a GCF goes out first. And then your remaining, you have a 6 minus 2x. And there you go. Okay, so that's that part. All right, so now we're going to factor using grouping. So one thing that's really great with grouping is you have to have an even number of terms. And from there, it's pretty straightforward. So we obviously have 1, 2, 3, 4 terms, so we're good. Once you have an even number, you split it up into 2 even groups. So put these into a group, and I'm going to put these into a group. Okay, so we're just splitting them apart. So now what you're able to do is you can individually look at each group. So just pretend that we just gave you guys 12x to the 4th minus 9x cubed. There was nothing else, just that. And I asked you to find the GCF. Well, then you should know, okay, 12 and 9. Both their largest, their GCF is 3, okay? X to the 4th and x to the 3rd, the largest GCF is going to be x to the 3rd. Okay, so from there, that's what you pulled out, and you look at what you're just dividing. So let me erase this so we have room. So once you identify the GCF, that's what you divide out from each term. So 12 divided by 3 is 4. X to the 4th over x cubed, you just subtract, so you're just left with x. And then the second term, 9 over 3 gives you 3, and the x's are gone. Okay? So now we're going to do the same thing over here. So both of these are divisible by 5 as our GCF. This first term, 20x, is the only one with an x, so we can't pull that out. So we just have 5. So 20 divided by 5 is 4 with the x still, minus 3. So just looking at what we have right now, 4x plus 3 and a 4x plus 3, that's what we want. We want to make sure that we have the same thing so that we can pull that GCF out in front. So it's gone, and left over 3x cubed plus 5. And there you're factored. You have your 2 binomials that are being multiplied together. Okay, so I'll do one more of these, and then hopefully you'll be good for this part. Okay, so let's just jump down to, I'll just jump down to D so that I have a little bit more space. Okay, so we're going to put them into 2 groups, and then find the GCFs of each group. So the GCF of the first group, 4 and 24, the thing that they have in common is actually both 4. And then x cubed and x, the largest thing that they have in common is x. So we're going to pull out a 4x. So that is what we're dividing these by. So 4 divided by 4 is 1. X cubed divided by x is x squared. And then 24x divided by 4x is now just a plus 6. Okay? So So now x squared plus 6 right here, there is no GCF. So we just are going to write plus x squared plus 6, which is okay because x squared plus 6 and x squared plus 6. That's great. So we divide both, by x squared plus 6. And then you're left with x squared plus 6 out front because these are gone. Now, this is where it can get a little tricky. You have 4x. But when you divide the same thing on top as on bottom, it doesn't just go away. It technically equals plus 1. So there's our factored form. Okay, so try those other ones, and if you want help with any more of these from these sections, let me know.